Carles Miralpeix, member of the innovation team of FGC, a railway company based in Barcelona, and I will talk about multimodal parcel delivery, the integration with public transport into last mile logistics. The rapid expansion of e-commerce has transformed last mile delivery into one of the most critical and complex segments of urban logistics. Cities are experiencing increasing pressure due to higher delivery frequencies, fragmented demand, and rising expectations for fast and reliable service. In this context, multimodal parcel delivery emerged as an interesting approach that integrates multiple transport modes within a single logistics chain. A key idea explored in recent research is the potential use of public transport systems as logistics vertebral column, using underutilized capacity. However, this assumption must be treated carefully, as capacity availability is highly dependent on temporal and spatial conditions, particularly in peak hour congestions and operational constraints that will be explained during this model. The challenge of last mile delivery stems from both demand side and supply side dynamics. On the demand side, the growth of e-commerce has led to a proliferation of small individualized deliveries with increasingly tight time windows. On the supply side, logistic operators face congestion, inefficient routing, and high operational cost, especially in dense urban environments. These issues are compounded by significant externalities, including greenhouse gas emissions, noise pollution, and the occupation of scarce urban space. Importantly, these challenges are not purely logistical, but are deeply rooted in the characteristics of the urban structure of each city, consumer behavior and culture, and regulatory frameworks of each city. The integration of public transport into logistics system can take several forms, ranging from shared use models, where parcels are transported alongside passengers, to dedicated freight services, operating on existing infrastructure. Also, the model can be based in a hybrid mode, using part of the space of a car for small parcels and the rest for passengers, for example with carriage like the one you can see on the picture. Stations can also work as micro-hubs, enabling consolidation of the distribution. Operational strategies include time sharing, where deliveries occur during off-peak hours, and space sharing, where designated areas within vehicles are used for freight. While enabling technologies such as digital platforms, IoT tracking, and optimization algorithms support these systems, many models remain theoretical and rely on simplifying assumptions that may not be held in the real-world conditions. Some of these theoretical studies can be found in the bibliography at the end of this presentation. Numerous pilot projects have explored the feasibility of integrating public transport into last-mile logistics. Rail-based initiatives, including cargo trams and metro freight systems, have demonstrated technical feasibility in several European cities. Other approaches involve the use of buses for parcel transport or the transformation of stations into logistic hubs. Emerging solutions combine public transport with autonomous delivery technologies, such as sidewalk robots or drones. Despite promising results, most of these initiatives remain limited in scale, often relying on public funding and facing significant barriers to long-term implementation. In the bibliography also, at the end of this presentation, you can find scientific papers and information about pilot tests or studies done for European cities, like Madrid in Spain, Saint-Étienne in France, London in UK, or Carluche in Germany. Successful implementations of multimodal parcel delivery tend to share common characteristics. They are typically located in dense urban corridors with predictable demand patterns and benefit from strong institutional coordination between stakeholders, private, public, and consumers. It helps to solve traffic problems related with delivery of goods in these areas. The use of existing infrastructure minimizes capital investment, while digital tools facilitate efficient operations. The use of low passenger demand slots of public transport help in the optimization of the service, reducing also the investment needed. And also the adaptation to the urban reality with different options like the use of lockers in stations or multimodality of transportation, depending on the city context, emerge as a good solution if it is adapted. Notably, as you can see, the success is less about technological innovation and more about organizational alignment and spatial planning. Despite its potential, the integration of public transport into logistics faces numerous barriers. Operational challenges include conflicts with passenger services and limited capacity during peak hours. But also, the logistics of enter and exit the public transport service by the freight can affect travel time of the service, as more time is needed in stops or stations, which increase the total travel time of the service. Economic barriers arise from uncertain demand and high coordination cost, and it affects the alignment between stakeholders. Regulatory constraints such as safety requirements and institutional fragmentation further complicated implementation. Technical limitations, including infrastructure constraints and lack of interoperability, also play an important role. Overall, the most significant barriers are institutional rather than technological. For example, some countries or public transport companies have legal regulations regarding the transport of goods in their vehicles. The success of multimodal logistics systems depends heavily on viable business models and effective governance structures. Key stakeholders include public authorities, transport operators, logistic companies, and technology providers. Various business models exist, ranging from publicly funded systems to private or hybrid approaches. However, the lack of clear revenue streams and the need for coordination among multiple actors often hinder scalability. Without a sustainable economic framework, most initiatives remain at the pilot stage, as also you can see in the bibliography at the end of this presentation. Exploration of automation, AI, smart city integration, and emerging delivery technologies are some of the options that can be approved for future innovations. Emerging trends in multimodal logistics include the integration of artificial intelligence for route optimization, for example, the use of autonomous delivery systems, as the one that you can see in the picture, that is one tested during the Greenlock project, and also the incorporation of real-time data within smart city frameworks. While these innovations offer significant potential, many are still in experimental phases and face challenges related to regulation, cost, and public acceptance. But it's important to remark again that, as I explained before, the success of this kind of implementations is more about organizational alignment than innovation. But of course, innovative solutions can help in it. In conclusion, integrating public transport into last-mile logistics represents a promising but context-dependent solution. While it offers potential benefits in terms of efficiency and sustainability, its implementation requires overcoming significant institutional and economical challenges. Ultimately, it should be viewed as part of a broader transformation of urban logistics systems rather than a standalone solution. Here you can find the references and articles used for preparing this presentation and also for having more information about the theme. Thank you very much for your attention.